All right, let's start with a story. There are reports of a classified system, sometimes called ghost murmur, that can detect a human heartbeat, even if the person is deep underground. The idea is that it uses quantum sensors, basically engineered diamonds, to detect the electromagnetic signal from the heart, and then uses AI to isolate that signal from the noise. If that's true, this isn't just advanced technology. This would represent a major breakthrough in physics. So today, let's test that claim. A heartbeat is an electrical event. A wave of depolarization moves through the heart muscle that produces electric fields and magnetic fields. But here's the key idea. The heart is not a transmitter. It's a localized source. At 1 hertz, the wavelength is about 300,000 kilometers. That's roughly the distance in one leg of Artemis II's recent trip to the moon. So if this were a radio wave, you'd need an antenna the size of a planet. So no, this is not a 1 hertz electromagnetic broadcast. Now the system is described as using quantum magnetometers, and that part is real. These sensors are incredibly sensitive. They can detect extremely small magnetic fields and control laboratory conditions. So the real question is, what happens when you move far away? Let's be extremely generous and give this every possible advantage. Suppose the heart's magnetic field is 10 to the minus 10 teslas, even at a meter away. That's already a very optimistic assumption. Now the heart behaves like a magnetic dipole, which means that the field falls off like 1 over the distance cubed. So as you move away, the signal drops very fast. At 100 meters, you're down to 10 to the minus 16 teslas. At 1 kilometer, 10 to the minus 19 teslas. For an aircraft, somewhere between 10 and 68 kilometers, that's roughly up to 40 miles, the field strength goes from 10 to the minus 17 teslas to 10 to the minus 20 teslas. Now compare that to the Earth's magnetic field, which is about 5 times 10 to the minus 5 teslas. What does this mean? It means the signal you're trying to detect is roughly 20 orders of magnitude smaller than the background field. That's not just a weak signal. That's a signal buried so deeply in noise that for all practical purposes, it isn't even there. It would be like trying to reconstruct a whisper that is weaker than the thermal noise in the air molecules themselves. At that point, the limitation isn't the sensor, it's the signal-to-noise ratio. The signal is so far below the noise floor that for any realistic measurement, it's unrecoverable. In controlled lab environments, you can sometimes recover weak signals by averaging, but that requires stable conditions and repeated measurements. None of that applies to a moving aircraft scanning a battlefield. Now you might think, okay, but what about AI? Could it filter out the noise? Here's the key principle. AI cannot recover a signal that is not physically above the noise floor. If the signal is buried by factors of billions and billions, there's nothing to extract. And if the person is underground, things get even worse. Rock and soil, they distort the signal, they introduce additional noise, and they further reduce what little signal remains. Now to be fair, there are ways to remotely detect a heartbeat. At short distances, radar can detect tiny chest motion. Thermal imaging can detect people. Search systems use beacons, but all of these rely on signals that are much stronger than the heart's electromagnetic field. So what do we do with a claim like this? It could be a simplified explanation, a combination of multiple systems, or something entirely different being described in a dramatic way. Physics gives us a clear conclusion. The heart does not radiate a usable long-range signal. Its magnetic field drops off extremely fast, and the signal levels are far below detectable limits at large distances. If you could detect a human heartbeat from 40 miles away, you wouldn't just have new technology, you would have discovered new physics. At this point, there are usually 2 kinds of responses. One is, maybe this is based on alien technology, something we don't understand yet. The other is, this must be some ultra-classified breakthrough, technology that's just not yet public. Now, I've had some exposure to how advanced research and defense technology actually work. And I'll say this carefully. Even in the most cutting-edge environments, where you're pushing the limits of sensors, signal processing, and physics itself, you are still constrained by the same fundamental relationships we just worked through. Signal strength, distance, and noise. These don't just go away. You can build better detectors, you can reduce the noise, you can process data more intelligently. But you don't get to pull a signal out when it's 20 orders of magnitude below the background. At that point, you're not improving a system, you're asking for a completely different set of physical rules. If you want to dig deeper into physics concepts like this, how signals propagate, how fields behave, and how to test big claims with simple calculations, check out the Prodigy Physics channel. We break it down step by step, so you don't just learn physics, you understand it.